Welcome back. Again, if you're sitting on this side, you may not be able to see Mac. So if you want to, please move on this side so you can see Mac. It's a little bit of a weird structure that we have here. All right, so it's my pleasure. Okay. You mean the people on Zoom? Oh, me. Okay, I'll be closer. Okay, it's my pleasure to be a moderator for this panel with 3 in-person panelists and 1 over at Zoom. We're going to start with a very brief introduction of all the panelists, and then we'll get to the questions. I guess I'll start with myself first. I did already introduce myself in the morning in case somebody just joined. My name is Shirin Sohrabi, and I'm from IBM Research, been there for 12 years. I mainly work on AI planning and applications of AI planning, and more recently in the area of planning and large language models. All right, so we'll start with Michael.
So, similar to Shirin, I also work at IBM Research, 11 years, working on planning and building planning technology for the most of my career. And recently I've got interested in this field or integration of the field of language models and planning. And in general, I'm interested in seeing what's happening with language models when they are tasked with planning. How we can use this technology in a way that is efficient, correct, safe for planning.
Okay, thank you. Karen.
Hi, everyone. We just spoke, you probably know who I am, but very briefly, I'm Karen Myers. I run the AI Center at SRI out in Menlo Park, California. My career, I've always been very interested in human-in-the-loop AI systems, with mixed initiative planning being a major focus for that. And of course, having LLMs available now as a tool, I think is something that really makes it possible to do things in the field of AI planning that we haven't been able to do previously because of some of the challenges with creating models and enabling humans to interact effectively with AI planning systems.
Thank you. Mac?
Mac Roberts. I work at the Naval Research Laboratory, at least for now. And so I've been working in planning, learning, and plan execution for a while. Fun fact, my life ambition is to punch out at Mars. So let's see if that happens.
Thank you. And to you, Swaroop. Can you hear me?
Yeah. Yeah, my name is Swaroop. I'm a research scientist at Google DeepMind, working on Gemini. So I basically work on large language models development end-to-end, mostly focusing on instruction tuning and reasoning, like how can models follow instructions better, how can they reason better, and more recently interested in planning.
All right, very good. I'm going to start with a set of questions, but if you have any questions, we'll take those also. I'll try to be brief my questions, and let's see what we do with respect to time. So think about your question, and there will be a time that you can ask your questions as well. And if you want, you can come to the mic so that people can hear you better. All right, we'll start with the first question. So recently, Amazon announced that they're using automated reasoning to reduce AI's hallucination. They hired experts in symbolic AI. They even said, we hired so many people that we are in danger of university systems not being able to hire enough people to teach. Now, connecting this to this bridge into planning, ensuring that the output of an LLM is valid and some guarantees are possible, especially in cases that the answer is not known. What are your views to ensure that the answers given by a large language model don't fall into this hallucination and can be used successfully even in some mission critical situations. And for this, we'll start with Mac.
So, given that I already said this during my talk, it won't be a surprise that I'm not as worried about hallucination, at least at the outset. I fundamentally think that these are inductive approaches. They're designed to do this sort of generative, creative, like mind. So in terms of how to get it so that and actually make it a sort of a safety bound cards, there's ways to adapt what they're doing. I also just wonder if, I really liked your approach, Michael, where you're using the LLM in a focused way. I think, Karen, you also had a focused way, a limited way of using it, and that seemed to be one direction. So the approaches I saw today, those are, I think we should embrace the hallucination.
Very good. And Karen.
I agree with Mac. Embracing hallucinations is a good thing if you're using them in the context where you're. Yeah, so by all means, use LLMs to try to come up with plans, but you can't trust those plans, right? You have to validate them after the fact. I apologize. Some of you may have heard some of this when I got asked some similar questions after my presentation this afternoon, but there is a lot of resistance in the commercial sector to deploying these technologies, the risks associated with hallucinations. So, it is something that both the research community and the commercial world are very concerned about, which is certainly spurring a lot of activity in Silicon Valley to try to come up with techniques to sort of eliminate hallucinations. Actually, it's amazing how many products you can see being marketed now that say they are hallucination free, which we all know is just possible unless they never answer anything. I do think that this is a great opportunity for the planning community, also the formal methods community, in terms of designing these kinds of hybrid systems where you use LLMs to help with some part of the problem, but then you've got these principled techniques that can be used to provide to check the homework, basically, to make sure that what these systems are suggesting are actually viable solutions to the problem.
Michael?
So I really don't have much to add what was said here in the second part. I do want to refer to the first part of it. And I think that when hiring too many improving to Amazon or any other company, it might be a good thing, but also I think there aren't too many people are teaching this or topics already. So I think that teaching more of what deep proving is, what start solving is, what planning is. At the beginning of the AI classes, and having these students, the future researchers actually know something about this, will prevent us from developing some of these law of thought papers that were recently generated, because to allow people to actually know what the search is, what are the pain points, and where can you actually use the language in a way that actually will help the search, but also will produce quality. So I think the education part of this and having topics at the university or in would actually be a good beneficial for these companies as well.
Absolutely. Great. And Swaroop.
Yeah, so I think hallucination is a feature or a bug depending on how you use it. Do you want, like, say, it's a
Sorry, it's a bit too loud for us. I don't know. I don't want to touch anything.
What?
It's too loud.
Swaroop, can you repeat? Can you say something?
yeah?
It's too loud.
Can you hear me?
It's controlling it. Okay,
Okay.
can you say
Can you say
something?
something? Mike?
Maybe I can talk little softer, maybe.
Okay, great.
Is
Sorry.
it better now?
Okay, thank you.
Wait, yes.
Okay, go ahead, sorry.
Okay. So I was saying like hallucination is a feature or bug depending on how you see it. Like say for example, if I want a model to write a poem for me or write a story for me, don't I want my model to be creative? Yes. Then I mean, if I want the model to be creative, there has to be some kind of hallucination or more like extrapolation, generalization. Like if you see the move 37 of AlphaGo, is it a hallucination? I mean, well, we want model to be more creative in expressing beyond the training data. That is like the regarding hallucination. Regarding the other part, the first part, you talked about hiring humans to teach the model. So there is always a trade-off in that. Like, of course, there is actually a nice plot in the AlphaGo paper where you learn from, the experts, Go experts, where you go versus if you try to generalize, try to learn from scratch and be more creative. So there's a trade-off. Like probably to bootstrap or to warm up the model, we need some kind of humans, but then I think the model need to self-improve itself and self-learn to be really useful at the end.
Very good, thank you. So the next question is, sorry. Sure, go ahead, yes.
So in the dark ages,
Can you use the mic, it just is hard for people.
in the dark ages, back so far long ago as June of 2024, there was an interesting paper that was titled ChatGPT is bullshit. It made some arguments in regards to what hallucination is, both in humans as well as in these systems, and they differ tremendously. And I think we're not addressing this here. I hate to disagree with some of you, but there's a difference between the way it's hallucinating and the way in which I would argue we would like it to, say, have differences from the way that we would like it to operate. We'd like to have some guidance that we would like to provide and not let it do some absolutely insane things for us. And so there seems to be a middle ground there. And I'd be interested in some of the comments of the panelists on this.
And
I think there is, so in planning, for instance, planning a search, for instance, we can actually define rather well what hallucination is. And for instance, relatively well. I mean, for instance, a plan action that doesn't exist is a hallucination, right? Like swapping two blocks at the bottom of the tower, this is the right thing to do, but there is a huge thing that make it happen, right? It's not one action. What human by the AlphaGo move 37 or whatever that famous move is, that's not a hallucination. This is moving away from the common patterns, but it's still within the right moves. Right? It's still a correct move. It's not a hallucination. Yeah. It's actually something that we want, right? We want to explore things that we haven't explored before.
Yeah, that's a really good point. I mean, hallucination is such a loaded term, right? What does that mean? I mean, people use it to mean that it said something that wasn't true, but it's really just synthesizing things, it's generating things. And as you say, sometimes in certain contexts, it's really good to be synthesizing things, and others it's not, so.
So Clay Shirky is a New York University professor, and he said that it's not information overload, it's filter failure. And I think maybe this could be applied here, right? The idea is not so much that we have a problem with the device that is producing spurious responses, but that we have no way of capturing that on the outward side, sure that it's correct going past that. But when I was thinking of hallucination, embracing it, I was clearly thinking, assuming that it's correct, right? Not that it's always going to be incorrect.
Sort of like thinking outside of the box. But did anybody else have any other?
Can we have Mishra?
Oh, yes. Sorry.
I think it's the responsibility of the tools. Like we have like various verifiable tools, like say in case of games, it's a perfect verifiable system. In case of reasoning, there is Python, other symbolic tools, where use that feedback to detect or like guide the models towards feasible solutions and not hallucinating something like absurd. And that is actually increasingly more and more important. The use of tools. Yeah.
Amoha? If you use the mic, it's a bit better. Yes.
People on Zoom cannot hear it.
Okay, can you hear me now? I feel like that, sorry, old ad that used to come on the cell phone. Okay, so if you can hear me, the question I was going to go back to is, Shirin, the one you were asking, how do we make sure that the LLM doesn't make some mistakes? My own perception is that when you build any such system, whether it's LLM or a planning system, we start by making certain assumptions, we start by making certain representational choices, and we start also by committing to certain kinds of update processes. Once we do that, there are going to be consequences of those choices. And then if we go back and ask the system, why are you not doing this? I don't think an LLM is built for doing the kind of planning that you were talking about, the classical planning. Instead, it can help you in different ways. I mean, I have Subarao behind me. He's written papers on this, so I'm not going to go into detail. But I'm just saying that if we then go back to the LLM and say, hey, why aren't you giving me correct plans? I would probably say that's being unfair to that system, because that's not what we expect, given the choices we've already made in the representations and updation processes. Instead, we should, once we have made those choices, we have to live with the consequences, or we have to go back and change that. We don't sort of say that I'll keep all those commitments as they are, and somehow it should work by just giving it more examples. I don't know what others think. Stop.
I was gonna, yes. No.
Yeah, so as soon as Swaroop basically mentioned 37, move 37, I cringed because move 37 is not hallucination. Thank you, Michael, for pointing out. Just because you didn't expect it doesn't mean it's not correct. There is a distinction that we need to make between things that are correct, especially in formally verifiable things, and things that don't have to be correct as long as they lead to correct solutions. So for example, even though most of us are here seem to be talking about LLMs quote unquote, reasoning trace ones, the O1, R1 sorts of things, the post facto post hoc accuracy for the O1, R1 is higher, way higher than for the simple LLMs, but they hallucinate the reasoning traces. So if you actually try to make sense of the reasoning traces, sometimes they make sense, sometimes they don't. And so the real question is, what do you actually care about? If you want correctness on the plans, right? I mean, then 37 is not a hallucination at all, because it actually did lead to a success, of the thing. I would have thought it is a hallucination if after some random move it said I win, and then that left the room. That would be hallucination.
All right, we will move on to the next question. So the next question is mostly about agents. So we heard the word agent during the bridge several times, and there's a lot of attention to agents these days, and a lot of different agent frameworks, a lot of different popular papers, SWE bench, SW agent, and so on. And the question here is, what about evaluating these agents in a more unified, general way? Do you have any thoughts about what should happen? What are your insights in regard to having an evaluation framework around agents? So for example, this morning, Harsha talked about LM Eval Harness, which is an evaluation framework for many different benchmarks, reasoning benchmarks, but we're not so aware of many different efforts around evaluating these agents. Any insights, any thoughts about that? I guess we'll start with Swaroop first this time.
Yeah, I think so there are like different kinds of agents, like depending on the task of interest. And I would say definitely the easily verified ones are like Sui Bench, or like which is like more general software engineering. They're like more machine learning and easily verifiable stuff, like fixing a GitHub issue and doing some experiment and plotting a graph and all those things. And then there are these other ones like planning trip, like we have this planning, making a travel plan or calendar scheduling or like trip plan, those kind of thing. You also can, in a constrained environment, you can also verify because like you can have constraints so that there are only few possible plans exist. So depending on like what is more real world, so I would hunch on the I would actually argue on the more on the former side, because a lot of tools are being built using software engineering agents, and it's sort of the backbone. So there's a lot of interest. Apart from the fact that a lot of this competitive coding can participate in code forces or IOI or like IMO for math. So I think those probably is you see a lot of agents these days, and I think we need more reliable. I think one of the key problems in those benchmark is this data contamination. So because when we train, it's been seen that like some part of the data from the Sui bench was in training, and there are some reports here and there it's coming. So how can we avoid that and keep on creating new benchmark, because language model had their knowledge cutoff date. So LCB, this live code bench, like they actually keep on updating the benchmark every few days. So more like dynamic benchmark and yeah, those sort of thing. That's interesting.
We also talked about that slightly in the morning. All right, Michael.
Okay, so it depends on what we want to evaluate. If you want to evaluate the planning capabilities of agents, of language model agents, for instance, we in planning community have reached, is it better now? Yeah, so in planning community.
Hear you unless you're speaking.
In planning community, we have a rich history of evaluating planning capabilities of either in domain dependent setting, optimal planners, non-optimal planners, and we have particular methodologies. We have established metrics for comparing them. We have competitions that allow us to test domain-independent planners on previously unseen instances and previously unseen domains that the developers of the planners couldn't have access to before. So we don't necessarily have that issue of contamination, and we can do the same thing here. I think we haven't been able to technically bring the community yet to the same point, in the sense that we are not able to provide framework to run these agents externally, measure the use of resources that because they're very different, right? And many of them require hardware that no one has access to except for very few. And how do you measure the performance of some monster like O1 or 3 versus something that runs on your local laptop? How do you compare that in terms of how long it took to solve the problem, right? And not only in the quality of the solution that you're getting. So I think it's more of a technical engineering problem at this point than something that we need to investigate from research perspective. But nevertheless, I think we need to get there. And I think we need to be able to run competitions for agent LLMs agents.
Right. Thank you.
Yeah, so there is the engineering for multi-agent systems group. They usually meet at AMOS, and I'm wondering if they might have some hints for how we could do that for LLM agents. They tend to be focused on maybe object-oriented languages for agent systems, like CAN and I'm forgetting some of the names of their languages, but they may have some ideas there. In the broader sense, I think that what you decide to evaluate is going to depend on your application. We deal with a lot of what's called mission critical kind of planning, where a mistake could really be disastrous in the worst sense that you could imagine. So in those high cost of failure environments, you really care a lot about how you're evaluating things. And another, I think, dimension, and these could be still engineering. I don't know if that's going to be the case, but the other is how good is the answer, or what is the utility of a good answer? And then the last part is, I mean, agents is this amorphous, another amorphous term, right? So this is a complex phenomena. As a scientist, I don't know how you break that down and begin to answer scientific questions about such big systems. I think that's a whole debate in itself. So I'm not sure I know the answer, but.
No, I'll just add a few more. I mean, agree with everything that the other panelists have said. But there's a broader point I wanted to make about, I think the community is too focused on benchmarks, right? We're looking at this question of accuracies for generative AI. And Michael touched on resource consumption. That's another really critical one once you start thinking about agents, because as his presentation earlier today showed, that there can be a huge difference between how more traditional approaches consume resources versus when you're invoking an LLM multiple times, many times in order to come up with a solution. But more generally, there are other dimensions as well that we really need to think about when we're evaluating both generative AI systems and more specifically agentic systems. So looking at other questions for agent-based systems, what's really critical there is, do they adhere to the guardrails that you put in place for them? As Max said, if you want to deploy these, I mean, you said mission critical domains, but even kind of trivial domains in the grand scheme of things, travel planning for somebody, there's no way I'm going to trust an agent system to go book a vacation for me, because if it, it decides that it wants to book it for me, 5 times rather than 1 time, that's a big outlay from my pocket to cover those extra expenses. So there are these other dimensions I think we really need to consider, especially for agent-based systems that might be taking actions in the world that can have real consequences.
Yeah, I'm reminded actually of when one of our postdocs started looking at this, and the first plan that came back from Travel Planner was fly to San Francisco and have a meal in Chicago. Wait a minute. You do know that taking a flight means that we're going to be in the other city, right? So
it doesn't know that.
No, it doesn't. That's the very point. Yeah.
So I wanted to sort of follow up on that. You already touched upon some of these priorities, and we heard Michael talk about cost of these models. What do you think should be priorities? I mean, you mentioned guardrails. What other priorities these papers or these recent maybe graduate students or researchers should focus on? Start with Michael.
So my point of view is that when you're doing something, you're doing it for a reason, right? I mean, even the curiosity should be driven by some desire to understand better or become better at something, right? And when you just run the language models for the sake of just try to see what, like, throw the spaghetti and see if it sticks. Thank you. That shouldn't be the mode of operation, right? So I think that people who want to tackle problems need to understand the problem, right? Before they try to devise a solution, they need to understand what the problem is. What are the pain points of existing methods? What's happening? What was done in the field already? Because no one, or rarely, you are the first one to tackle an important problem. People usually looked at it for a while before you came. So I think these are important questions that you need to ask yourself before you try to reinvent everything with language model. And I'll let the other speakers.
Karen, do you want to add anything?
Yeah, I agree with what Michael said. I mean, we're researchers, we're scientists, we're interested in understanding things. So in some sense, evaluating everything is good. But I think if we want to deploy these systems, we really have to think hard about their impact in the real world and what the ultimate consumers of these technologies are going to be doing with them. So also really taking seriously, human in the loop type evaluations. So it's one thing to build a system that a PhD in AI can use effectively versus, your next door neighbor who doesn't have any technical training. So I'll say that. I mean, another thing is I think we really need new methods for evaluating AI systems. So think about the RAGAS framework, which is a really nice piece of work, thinking about a whole new set of measures basically for looking at RAG-based systems and understanding whether or not they're working effectively. So I think that's another opportunity in the community to really think about what's different about the classes of systems we're building now and how should we be measuring them.
You want to add anything?
No, I think those are all great comments. Yes, I have a question in return for this. So what kind of planners can produce planning models without fully instantiated planning models? So, if we're going to ask an LLM to produce PDDL or produce a plan, it's okay if it's incomplete. We just need a planner that can fill in the gaps, right? And so, and I think we do this in daily life, so it seems reasonable to expect that we would want agents to do this too. If I know I need to go, I'm in a new town and I need to go to the grocery store and to pick up something, I don't need to know where the grocery store is, right? I can make a plan to go to the grocery store, and then when I'm ready to go to the grocery store, then I fill in the gap that I don't know where the closest grocery store is. And I know I have several different possible ways I could do that. There are a variety of approaches that manage and handle these kinds of ambiguous situations with incomplete models and incomplete plan specifications. I'm wondering if those could be helpful in this context too.
Sir,
Yeah, I agree with the panelists regarding the type of problem should work on. It should be more real world and should be more useful rather than travel planning and those kind of stuff. But I'd like to point out one key learning we have as a community over the years. So back in the day, before transformers or like in NLP and computer vision, we all have this syntax and all this human-driven features, a human-driven notion that is sort of like lost as deep learning came and model learns itself. Transformer took the community, all these different fields. So my only advice is it's very tempting to use our own human intuitions and human learning and directly put it into the model. Instead of that, we should trust the model that there are some capability that automatically emerge, and sort of like it's very difficult to put that directly into the model. So like so I think that part need to be considered, that less inductive bias as possible, more general stuff. We should have that better lesson from the community. And I think like we have lots of these overloaded terms like hallucination, generalization, all those things, but the key summary is less human intervention.
very good. We have some questions in the audience. Yes.
So I'm gonna disagree with him.
Okay.
Right? So no, that's not, I mean, like, the knowledge that we have about any domain is crucial. So we build this huge system and then say, okay, we are going to introduce inductive bias. That knowledge is already there. Why not use it? To say that human knowledge is like, we shouldn't use it is, I think, folly. Like, we should actually use it and use it to drive whatever learning system. Learning does not happen in a vacuum. Learning should not happen in a vacuum. And learning is end-to-end, as they call it. It's not really end-to-end. Without the considerable engineering works, no deep network really solves any problem, right? So there's a considerable bit of human knowledge that goes into engineering these systems. So while I'm all in favor of learning these features and other things with the deep network, to say to take the human out or to not use the language, I think is actually not the right way to go. And I'll just add one thing, because you are asking what should be a priority. It would really help with people who write papers also talk a bit about the limitations, things that don't work with their system. Because I've tried this with my graduate student, and this is true probably of every academic or whoever has worked with it. Whatever they say in the paper never works for us, right? I struggle each time to do with the robot, to the extent that I have no student doing anything with a physical robot, even touching a large language model, right? Or any sort of deep network system. It works beautifully, does better than whatever results are reported in the paper. But the problem is that if you keep saying that this solves all problems, this solves all problems, without talking about the limitations, it only comes back to bite us.
Good. Yes, go ahead.
Okay, so this point is more towards like directed towards Swaroop. So you are saying that we do not want, like, we should trust the model more, right? And not take into account, let's say, what human intuitions are. But then I think the major successes of LLMs that I have seen, which you also pointed out, like in Mathematics Olympiad, they were not just using LLMs, right? They used like verifiers, alpha proof, and these kind of other tools that can verify the solution of these LLMs. And these tools, uh, they had these human intuitions inbuilt into them, right? When we say that we have this verifier, these sort of rules that we have learned over time, and these are used to verify an output of these LLMs. So we cannot say that let's not use human intuition at all. Of course, these solutions for some domains can be creative, like you said, for the move 37 or something, right? But at the end of the day, that still followed the rules that humans build, right? So you cannot just discard them completely. That's all I want to say.
Okay. And now?
Clarify.
Yeah. So I think part of the problem with bitter lesson is there are bitter misunderstandings about the bitter lesson. Uh, it turns out that bitter lesson is really about RL, which basically has the verifier in terms of working in the world. And then if you allow an agent to really take its own, crazy amount of time working in the world or working in a faithful simulator, it might find shortcuts that you could never have thought about. For example, AlphaGo 37, right? LLMs are not RL. LLMs might help RL. LLMs might be helped by RL. LLMs are actually completely dependent on the human digital footprints. To say that we shouldn't be giving any knowledge to LLMs is kind of strange to me, because in fact, they only work because we give knowledge. Even as we speak right now, people are showing that if you give slightly modified pre-training data, then they get misaligned like crazy. So I think it's useful to kind of distinguish between when we should be providing knowledge. In fact, to me, I always think of LLMs as essentially approximate knowledge-based systems, because they've essentially scarfed down everything that we ever put on the web. And so saying that they should not be given any knowledge, they've already taken all the knowledge. If you, on the other hand, if it's an RL system and you're trying to provide control knowledge to it, that may not necessarily be a smart idea, is basically the point of bitter lesson, that as I understand it.
Good. And Swaroop, do you wanted to comment on that?
Yeah. So of course, like these are like pre-trained language models. That means when we pre-train these language models, we take the entire internet, almost the entire internet, and this internet is actually a collection of all the human knowledge which we train on. And even in the verifier setup, when we want to verify use tools like Python systems or any of the symbolic tools, which is actually developed by humans. So there is definitely a human factor. I think what I was commenting on is like the classical NLP systems or vision systems, where we limit the model's learning to how we represent information. For example, using syntax trees or using different features, or defining layers of the deep neural network based on how we interpret and how we think and reason. I think that is dangerous in the sense that it's limited by what we understand, but there might be something better which the model can learn itself. So of course, we use humans. I'm not saying to disregard humans, but when you design a system, design a network, to have more generality and less specificity as much as possible for it to scale well.
Okay. I guess, yes, if you have a question, go ahead.
Okay, so this I have a question for Michael because I like too much the work sorry the work but I have a question because you compared a lot of LLM in search approaches, but your work is more likely a wall model generation approach than then use a symbolic search. So my question is if there exist another approaches for domain generation or wall model generation using LLMs that could be interesting, or it is a powerful or an interesting file to explore in the future.
I think there are so many things that can be done. There are lots of people that talk about word models, right? In the sense that Jan LeCun saying we can learn the word models and then the problem is solved, right? The minute we have the word model, that's it, right? Planning is trivial. And I think they assume, and it's not Jan anymore. There are like other people who are saying that as well. I think they assume that these word models are differentiable, and they're probably not. In cases that we deal with, these are discrete problems, which with that switch that is not differentiable, right? It's not smooth, right? And it's not easy to solve with local search, and that's why planners do global search, right? I mean, that's some planners actually. I mean, the famous FF planner does a local search as the first greedy procedure, and sometimes it actually solves the problem rather quickly. But there is a complete search procedure after that, right? So my point is, you will have to do a search. You will have to find a word model in some representation that will help you with the search, because the successor function is not everything. It will allow you to perform search, but it's a necessary but insufficient criteria for solving large problems. Now, in order to use heuristic search, you need some heuristic guidance. You need to be able to prune some states, right? You need some dead-end detection. You need to be able to check whether your states, whether you have seen your states before, whether two states are essentially represent the same information, right? You need other methods like pruning the search in order to reduce the effort, right, of the search. All of these require some information that can be derived from models that are represented in a particular form. For instance, in planning community, we have been focusing for a while on strips that allows us to derive all these things automatically, right? We developed lots of methods that can speed up the search when the when the word model is represented with strips. Strip a little bit different strips. In addition to that, so I mean, in addition, when you learn the word model and you know something about the form of your word model that you want to learn, it's so much easier to learn it. Right? If you know that you need to learn preconditions and effects in terms of this particular set of predicates, it's so much easier to learn it. Right? And so much the learning is so much more efficient, right? Having said that, not all problems are easily represented in that formalism, right? And sometimes when you go into richer formalisms, I think the point is to be able to understand what kind of formalism you really need, and being able to capture your model in that formalism.
I have a response, unless, are you finished? Or, yeah.
Yes, I'm
Okay.
finished, and finally we have some possible in agreement between the people in the
Perhaps.
panel.
So this game, I've been thinking about this game because I want to turn it into a card game. My partner and I, we play a lot of card games, like rummy kinds of card games. And this is this 4-number.
The 24
Yeah,
game?
the 24 game seems
Right.
like a perfect one. I don't know if somebody's made it into a card game. But I was thinking, how would I play this game? And I'm not saying the way I would play it is the way we should have computers do it, but I would use a factored representation. I wouldn't think about all the possible models that I could create. I would
Okay.
think about the factors of 24,
Mhm.
right? Or the factors that go with plus and minus, and the factors that would go, not factors, but you know, the sets of numbers that make sense to add to 24, and the sets of numbers that work for factors. And I would try to create a hand that manipulated those. But the solution that the LLM came to didn't look at any of that, right? For the successor generation.
Well,
And yet, wouldn't you agree that that's actually a really desirable output?
so to be fair, we actually said to the language model what the state representation is,
Okay,
right? So you said this is a list of numbers up to 4, right?
yeah. So those are the rules of the game. But that's
No,
not
but
that.
we said the state is represented by a list of numbers,
Uh-huh.
right? So we kind of impose the representation of the language model.
But what I was saying is that I internally would create a new representation that helped me play the game better.
You can actually tell the language model that, right? And I bet it will think of something. I don't know. I don't want to say hallucinate, but it will.
Please do.
It will create something, right? That is a different representation. I don't know what that would be. It would be very interesting to check, right?
I mean, so
This is one of the things that we want to check, right? What kind of different representation we can have for these problems.
and how do you arrive at a representation? I think this is part of that abductive thing I was talking about earlier. Sometimes the way you arrive at a representation is you play with the thing and then you go, well, it's a lot easier if I just think about it this other way, right?
But the point is that we know what to ask, right? We know what kind of questions we want to ask the language model, right? Or ourselves, right? In order to derive better representations, better solvers, better solutions, right? And that's the main point, right? We as humans actually know what kind of questions to ask. We as humans know these questions because we are dealing with search problems for a while.
Very good. Sort of running out of time. I was wondering if anybody in the audience has any other questions for any of the panelists. And if not, we'll go around and for any last word from the audience. We'll start with Sohrabi.
Sure. Yeah. I would say, like, as a deep learning researcher, we believe in this law of compression, and that's what it means is, as the internet and world knowledge keeps growing, we design inductive biases and models that is able to compress the knowledge in a much generalizable way, and we believe that this compression capability of a language model is driven by generality and many of this general setup. I think I want to emphasize that as few years down the line, when we go back and see what we have achieved and what we have learned, I think generality and automatic emergence of different new behaviors beyond what humans can achieve. I think that is going to be critical if we really want to achieve superhuman level performance. Thank you.
And Karen?
I'll go back to the point I made earlier about, really going beyond benchmarks for testing. There's this maxim, Goodhart's maxim, that says once a measure becomes a target, it ceases to be a good measure. And I sort of worry that's what's happening in the field right now. People are embracing these benchmarks and we're getting better and better at them, but we don't know. I mean, some of that is progress, but some of that I think is the data contamination problem that people have talked about today. But it also sort of, I think there's a little bit of the teaching to the test going on here. So I would just encourage people to step back from the benchmarks. Benchmarks are useful, absolutely no question about it, but think about the bigger picture of how do we want this technology to be used and what's important in terms of assuring its performance with respect to all the different criteria that matter.
Michael?
Okay, so
Mike?
there are so many points, but I think if I need to choose one, I would like to reiterate the point that I made at the end of my presentation. We need to be aware of the footprint that using these models leaves, and we need to understand when to use them, when not to use them, how to use them, and just be aware.
Yeah, so if you've ever put dishes away in your kitchen, you probably have a good clear picture of what that task looks like. If you've ever worked with a toddler who wants to help you do that task, it's fundamentally a different task because now you're managing an entity that could drop glass objects or fragile objects or hurt themselves with sharp things or so on. And what I wonder is how LLMs are changing the face of our society, our research, or even our planning, right? We've been talking about it with respect to natural language and planning today, but I actually wonder in a wider sense, like the greater dialogue